So this is a titration question involving old phosphoric acid, so that's a polyprotic acid with the formula H3PO4, and standard sodium hydroxide. And when they tell us that it's standard, what they're telling us is that this is the known concentration. So we believe that the concentration of the phosphoric acid is 0.6829, but since they tell us it's old, they're giving us the hint that it's not 0.6829. And then the question goes and asks about some equivalence points. So I just want to point out some things. When you standardize a polyprotic acid with a base, each hydrogen gets neutralized, kind of like each molecule of H3PO4 will have the first hydrogen neutralized, then the second, and so on. You'd have a titration curve that kind of has like 3 different equivalence points. So I just wanted to make sure I covered some of that stuff. So at the first equivalence point, however many moles of H3PO4 you have, it requires an equal number of moles of NaOH for your first equivalence point. For your second equivalence point, however many moles of H3PO4 you have, you need 2 times as many NaOH because you've titrated the second, so from here to here, like this would be halfway to here. You need double as much to reach the second equivalence point. And then of course the third, you would need 3 times as much to reach your third equivalence point. So for the first equivalence point, because moles would equal moles, you can say the molarity times the volume, because molarity times volume equals moles, we'll go ahead and just put A for acid here, would equal the molarity of the base times the volume of the base. So when you plug in your 0.6829 molar and your 26.00 milliliters, at the first equivalence point, that would equal 0.8574 molar and the milliliters that you saw for. When you plug that in, you get 20.71 milliliters. So that's what we would predict it would take to reach the second equivalence point. And if the concentration of the H3PO4 was actually 68.29, then to reach the second equivalence point, we would expect the volume to be double that, or 41.42. So I'm just kind of make a little note that at the second equivalence point, which is what the next part of this question asks, I'm off the screen, we expect it to be somewhere around 41.42. But what they found is that it's only 37.81. So that means since it took less of the sodium hydroxide to reach the second equivalence point than what the calculations predicted, that tells us that the old phosphoric acid is not actually that concentrated. It's a little bit less concentrated than that. So you could go about this a couple different ways, but here's how I would look at it. If it takes 37.81 milliliters to reach the second equivalence point, then to reach the first equivalence point, it would take half of that. So I'm going to kind of like read that out so you can see. So if the second required 37.81 milliliters, and the first equivalence point would require half of that, which would be 18.90 milliliters. So the second part of this question asks, what is the actual concentration of the phosphoric acid? So I'm going to go back to, I went ahead and found for the first equivalence point, and I'm going to say, well, the molarity of the acid would times the volume of the acid would be the molarity of the base times the volume of the base. And so we know that the molarity of the base, because that's our standard, is 8.574 molar times the volume that we just found by dividing the 37.8 in half of 18.90 milliliters. And then we titrated 26.00 milliliters. So we're just finding the molarity of the acid. And when we rearrange and we solve for the molarity of the acid, you should get 0.6233 molar. And like I said, what that tells us, they probably had some old phosphoric acid and it was labeled 0.6829, but it turns out that it is less concentrated than what they thought.